is amount equals percent times base, which we will abbreviate A equals P times B. And so the base represents one of two things. So depending on the type of problem, the base is either the total or whole, or the value before a change. So there's sort of two types of percent problems that we work with. The first is where like the percent is just a percentage of the whole. So like if we said like 95% of people passed a test in the class, like we're not changing the number of people in the class. We're just talking about a particular subset of the class, right? So these people passed, and that's part of the whole. So in that case, our base would be like the total number of people in the class. That would be the whole, right? Whereas if I go out to dinner and I leave a like 20% tip, I'm actually changing the like the cost of my meal, right? I'm increasing the cost of my meal from the price without the tip or before the tip to the price after the tip. And so that would be, in that case, my base would be the value before the change. So it would be the price of my meal before the tip. So before I increased it by a certain amount. So depending on the type of problem, the base is going to be either one of those things. And then the other key to this equation, and what's going to really help us set things up correctly so that they work out numerically right, is that the percent and the amount always represent the same quantity. So like in the example where we're talking about 95% of people passing the class, if we had 100 people in the class, that would mean 95 people passed the class. So the amount would be the 95 people, the percent would be the 95%. But if instead we had like just 25 people in the class, well, 95 people didn't pass, right? So whatever 95% of that 25 is would be the amount of people that passed, but 95% would still be the percent of people that passed. So the amount represents that quantity in a set number of like people or dollars or whatever you're measuring things by, whereas the percent is just a ratio out of 100, but they're always representing the same quantity. So these first couple of examples, we're just going to, like all the numbers are given, we're just going to look at what the setup looks like and how we're going to label things and use the equation and see how like that percent and amount represent the same quantity. So we're going to start with our general setup is just a writing amount percent base. And like I said, that's our general setup. It has nothing to do with the actual problem that we're doing. So in addition to writing that, we want to label all three of these to correspond with the specific problem that we're working on. So our percent in this case, I usually look at percent first just because it's the easiest thing to find in the problem. So our percent is 80%. What is special about that 80%? Like what makes the 80% different from the rest of the students in the class?
They passed.
They passed, right? And so that's how I'm going to label my percent. So it's the percent that passed. And then, like I said, the amount always has to represent exactly the same thing. So you literally want to copy whatever you wrote for the percent. So this is the amount that passed. If those two aren't the same, then numerically the equation won't work because the way the equation is built assumes that the percent and the amount represent the same thing. So if you have the amount representing, say, the percent that, or the number of students that didn't pass and the percent representing the students that did pass, then numerically it's not going to work out. So that's why I say just copy, like don't overthink it. Like those words should be exactly the same. And then our base, in this case, we're just taking a part of the whole, so our base is just the whole class, so the total number of students. So it can be tempting because when we do math, like we really want to like get down to calculations, it can be tempting to start with all the numbers they give us. But I really recommend starting with the words, and then you can go back to the problem and pick out the things that you need. And that way, if there's like a little extra work to find one of these things, you're not just throwing numbers at it. You're like, oh, I need to do this to actually find the amount of students that passed. So what is the amount that passed? It's 20 students, right? So that amount always counts it in students, right, rather than in percent. And then the percent that passed is that 80%, which we always want to convert to a decimal before doing calculations with it. And if you ever find yourself making any mistakes with converting to decimals, just like on tests and things, I always think it's nice on tests to, like, I make silly mistakes all the time. So I think if you can avoid those, it's handy. Your calculator has a percent button on it. If you have this I mean, most scientific calculators have a percent button, but if you have this one, it's like second and then like the left parenthesis. So if you put 20 or 80 in this case, 80, and then do the percent button and hit enter, it'll convert it to a decimal for you. And that's just like one of those silly mistakes that you might make on a test when you're a little flustered that you can avoid by just using a calculator. Graphing calculators do not have percent buttons, incidentally. It's so funny because like, you know, like TI-84s or what have you, like will do like a billion things, but they won't convert to percent. I don't know why. So then do we know the total number of students? 25. And so our equation is A equals P times B. And in fact, we can see that 20 does in fact equal 0.08 times 25. So it's true. So I want you guys to do example 2. So just set it up exactly the same way we set the last one up. There's not a whole lot you have to do as far as like answering anything. We're just working on the labeling and the setup right now. I have to remind myself to resume recording. So we have amount. Oops. In this case, what do the amount and the percent represent? Good. And then the base is going to be the price before the tip. So it's a $45 meal, a $9 tip, which is also a 20% tip, which is 0.2. And 9 does in fact equal 0.2 times 45. And there's other ways on these increase and decrease problems, which we'll see a little bit more of later. There's other ways to set this up. Like we find it beneficial sometimes to have the amount and the tip represent the amount paid after the tip as opposed to just the tip itself. And we'll talk about like when that's applicable. It kind of turns out on some of the problems that you can choose either one as long as you're consistent, right? Like we wouldn't want to say amount paid after the tip is 54 and then the percent of the tip is 20% because 54 isn't 20% of 45, right? So there's often a choice about like what that amount and percent represent, and it's not that one of the choices is wrong. It's just that you have to be consistent or else, again, numerically, it's not going to work out correctly. So let's do some problems now where we actually have to solve for something. So our setup is going to be exactly the same as what we've been doing. Now just one of our values is not going to be a number, it'll be a variable, and we'll solve for it. So we're going to start again with amount, percent, and base. So in this case, we have like an acid solution. If we could separate the acid from the water, then 30% of the solution would be acid and 70% of the solution would be water. So the percent is the percent of acid in the solution, which means the amount is the amount of acid in the solution. And then in this case, that percentage, so that acid is just a part of the whole solution, right? We're not changing the amount of solution. And so the base is just the total volume of solution. Okay, do we know the amount of acid in the solution? No, that's our unknown, so that'll be X. What's the percent of acid in solution? 30. So 0.3. And then the total volume of the solution is 90 milliliters. Good. And you don't have to put units on that when you put it in your setup here. I kind of like to put units on it just because it helps me remember what my units are going to be like when I actually answer the question. But it's totally up to you. So now we have A equals P times B. So X equals 0.3 times 90. And that equation is never going to change. So one of kind of the nice things about these problems is like the setup is really all the work. Once you get past the setup, like it's always A equals P times B, no matter what. And so you're just kind of solving that equation. So X equals, what is that, 27? So there's 27 milliliters. Trevor.
Yep. Thank you.
There you go. You bet. You're fine. Better late than never. Okay. Of acid in the solution. Okay, so I want you guys to do this one. It's essentially the same exact problem. It's just that our unknown is different. So I'm going to actually leave up example 3 just in case you didn't get to write all that down. But the setup should be exactly the same. Even the labeling is the same. But then just where your variable ends up will be different in this one. And the setup is basically exactly the same. So all the labeling is the same. But the amount of the acid in the solution is given, so that's our 16 milliliters. We don't know what the concentration is or the percent of acid in the solution. And then the total volume of the solution is also given. It's 80 milliliters. So we have 16 equals X times 80, or you could write that as 80X also. It's a little more recognizable. Divide both sides by 80, we get X equals 0.2. So the solution is 20% acid. And it looked like all of you basically nailed that. Good? Okay. So try that one. So walking around, it looked like everybody had this. So what makes that 40% different from the rest of the class is that they check their answers, right? So asking yourself that question is a good way to like start getting an idea of how you might label the percent and the amount. So, and if you just wrote something like the percent checked, or that's totally fine. Like you don't have to write a bunch. Just it should be clear how you're differentiating that 40% from like the rest of the class. And so this is 40% the number of students that checked was 10, and then we don't know the total number of students in the class. So we have, this is 0.4. We have 10 equals 0.4x. So x is 25. So there are 25 students in the class. Any questions on that one? Make sure that you hold on to these notes and definitely get them out as you're doing your homework. I know, like, I feel like every semester, like, when we do this in class, everybody just nails it, and then people go home and, like, kind of forget. So, which is totally normal, happens to me too. Just, like, definitely, like, put your notes in front of you so that you can refer back to your examples and remember what we were doing in class. Because it's easy to revert back to sort of like the simple calculation way that we did this rather than like the algebraic way that we're doing it today, when you kind of forget. So we're going to talk now a little bit about percent increase and decrease situations. So this is where like something's actually changing, right? So in this case, the price of the coat is changing when we add the tax onto it. And so there's a couple ways you can approach this. The way I usually do it is, so we start with our amount, our percent, and our base. So I usually think of it as my final, like what I'm looking for is the total amount I'm going to pay, so the amount that I pay after the tax. And so I'm going to make that my amount. So the amount is going to be the amount paid after tax. But that means that my percent also has to be the percent paid after the tax. It can't be the percent of the tax because then the two don't correspond. So this is going to be the percent paid after tax. And then that means my base is the price before tax. And one simple way to remember what goes where on these is that base starts with B and like amount starts with A, as do before and after, right? So the amount is always like after the change, the base is always before the change. And this one you can do another way. Like you can make the amount and the percent, the amount and percent of the tax, so the 4%. As long as you're consistent, and then you just like you calculate how much the tax is and you add it on. The only reason I prefer this way is that if the unknown is the price before the tax, then we can't do it the other way. We have to do it this way. So I think it's simpler to do it the same way every time and not have to remember like when to do it which way. But again, like as with the problems we talked about yesterday, like there's multiple ways you can do some of these correctly. As long as you're consistent and you label everything appropriately, you should get to where you're trying to go. So, whoops. The amount paid after the tax is my unknown. What percent do I pay after the tax? Like, do I pay 4%?
It's 1.04%.
Right, so I pay 104%, right? Because I have to pay 100% of the price of the coat. And then in addition to that, I have to pay 4% for the tax. So that 100% is the coat, the 4% is the tax. So the total percentage I'm paying is 104%, which is also 1.04. And then the price before the tax is $75. So we have amount equals percent times base, and we get x equals 78. So the price after is $78. So now we're going to switch things around a little bit. We're going to use the same setup, but now we don't know the price before, in this case, the sale. It's not tax anymore. Now we're doing a discount, but it's going to be the same idea. We're going to make our amount the amount that's paid after the sale, as well as the percent being the percent paid after the sale. So we have amount paid after the sale and then the percent has to be exactly the same thing. And then your base is always before the change, so the price before the sale. And again, after is the amount, before is the base. So do we know how much we paid after the sale? Yeah, that's the 123, right? What percent do you pay after the sale? Are you paying 25%?
75.
You pay 75%, right? Because we start with the price of the item, and then there's a 25% discount, which means that the percent that we actually have to pay for is 75% of the original price. And then the price before the sale, we don't know. So we have 123 is equal to, 0.75 x, I think that was like 164. Is that right? Mm-hmm. And so the price before the sale was $164. So it can be tempting to and if you worked ahead, make sure that you go back and check that you got 164 exactly as well. It can be tempting on these to be like, oh, well, I'll just take 25% of 123 and then add that back on, and that should give me the original price. Why doesn't that work? Or does it work? I mean,
because that's what the percent off of the original was, and we don't know the original.
right. If we took 25% of 123, you get a different dollar amount than if you take 25% of 164, right? So what the amount is totally based on what you're taking a percentage of. And so taking 25% of the final price isn't the same as taking 25% of the original price, which is how they calculate discount, right? And so if we don't know the price before the sale, there is no way for us to figure out what the discount is to add it back on. And so that's why I set this one up this way, even though there's sort of a simpler way to do it, because then I can set this one up exactly the same way, and I don't have to remember when to do what. Because this is the only way you can do it. Because there's no way to figure out what that discount was in order to add it back on. So let's do one more. So on this one, again, we kind of have a choice, and there's not really a right or a wrong. We're looking for the percent increase, so we could make the percent just the increase. We could also make the percent and the amount the population after the change. I'll leave it up to you. What do you guys want to do? So we have amount, percent, base. Something's changing here. So the base has to be the population before the increase. So what do you guys want the amount and the percent to represent? I promise, it's not going to be wrong. You really have a choice, so.
Do you have it be number of population increase?
So just the increase? Sure, so the amount of population increase And this is the percent population increase. And like I said, like, you could make it the amount of the population after the increase, but then you would have to make the percent after the increase. So, like, there's two choices here, and neither is wrong. The only way you would get it wrong is if you made one of them the increase and one after the increase, right? Because then they wouldn't correspond to one another. What is the amount of the population increase? Right, we got that by just subtracting, right? So we did 10,992 minus 10,259. You said it was 733. And then the percent of the increase, we don't know. And then the population before the increase, that was 10,259. So we have 733 equals x times 10,259. And x equals, I believe, 0.07. And so it was a 7% increase. Make sense? Questions? Okay, again, use your notes when you do your homework tonight. It'll really help not like revert back to just doing calculations like we used to back in the day.